everyone, my name is Andi Fauzie Ramadan from Marine Engineering PPNS. Today I will presentation about my thesis. My thesis title is Additional Double Injector Using a Programmable HU with Dual Fuel System Pertamax Butanol on SE Engine Performance. First, I want to explain about my research background. Research background is a basic that includes the formulation of problems, concern, and purpose. 1. The high volume of vehicle each year has increased. In Indonesia, every year there is an increased volume of vehicle that make an increased use of fossil fuel. Every vehicle in Indonesia use a fossil fuels that make a fossil fuels rare and contains a gas emission. So I want to use a butanol for dual fuel system. Butanol is able to provide a perfect combustion effect, thereby reducing carbon oxide and hydrocarbon exhaust emission. Butanol has the characteristic of high oxygen content, which is it can delay ignition and produce better peak pressure. Development from mechanical tap to injection, this can improve performance efficiency and can reduce carbon monoxide and hydrocarbon. Problem statement. How to design butanol injection using a programmable HU on intake motor. How are the results of testing and measuring engine performance using a Pertamax butanol fuel with variation ignition timing? 3. How is the effect of the adding butanol to the combustion chamber on the engine exhaust emission? Why butanol? The advantage is 1. Similar characteristic to gasoline. Like octane number gasoline is 92 and butanol is 96. 2. Has more oxygen content than gasoline. Butanol have a 21% oxygen. 3. Easy to use than other alcohol. It means unlike ethanol or methanol, which requires a high engine ratio. 4. Able to reduce exhaust emission. This is because bioethanol contains oxygen, which can help improve fuel combustion so that it can reduce CO emission. Disadvantage. Butanol is more difficult to find. Butanol has a high octane number, so need engine mapping. Fabrication. This stage is the process of design, assembling tool for experiment. Design. The schematic is like this, what you see. First, from Pertamax tank to fuel pump through to the injector is controlled by HU standard and goes to throttle body to a combustion chamber. The butanol is like since a Pertamax. What difference is the control of injector? The injector is controllable with programmable HU goes to intake to throttle body and to combustion chamber. The output from engine is AFR, or air fuel ratio, and exhaust gas analyzer that contains emission like CO, HC, and NO2. And the output from the crankshaft is HP and torque, which is can see the graphic from a dyno test. Programmable HU on this experiment is to use change ignition timing standard to 2 degree forward and 4 degree forward. Assembling. First, we assemble the programmable HU in the front body of motorcycle. After that, we scan the standard timing ignition with application that can be we see at the laptop or handphone. After that, we can see the timing ignition standard, unlike the older motorcycle, which is old motorcycle use a fixed ignition timing. We see the ignition timing is changed every RPM, so we can change the ignition timing 1000 RPM until 11,000 RPM. 2 degree forward from standard like this. And we also change 4 degrees forward from the standard. So, what is the timing ignition? Ignition timing is the time set by the HU to spark the spark plug to ignite the fuel and intake mixture. When the piston go on the top dead center, the spark plug will burn the fuel and air in the ignition angel that is set by ECU. If the spark occurs to forward position, the explosion pushes the piston which is still moving up on its compression stroke, causing knocking, pinging, and possibly engine damage. If spark occurs too slowly, maximum cylinder pressure will occur. The piston has descended too far in the cylinder on its power stroke. This result in power loss and tendency overheating, high emission, and unburned fuel. This is a design for the injection of butanol. As we can see, the second injector, which means a butanol injector, is placed behind the first injector. The butanol injector controlled by programmable ECU and butanol came from the butanol tank to fuel pump, goes through the injector. Programmable ECU also can setting ignition timing to coil and coil to spark plug. The real assembly in motor is like this, and the butanol and fuel pump placed on storage sheet like this. Flowchart diagram. Flowchart diagram start. Problem identification and purpose, which was explained in the previous slide. Study literature. Data collection and determine a variable. The independent variable is timing ignition standard, 2 degree forward from standard, and 4 degree from standard. Dependent variable is horsepower, torque, gas emission, fuel consumption, and efficiency thermal. Performance test. In this case, I use a dyno test. Dyno test is a measuring instrument used to measure the torque and horsepower. The result from this test is like this. Because there are too many variables, I summarize it like this. Based on graph, the highest torque is produced by ignition timing of 4 degree forward from the standard produce 37.04 Newton meter at 2000 rpm, and the standard is 25.34 on the same rpm. Torque, as you know, the modification of dual fuel system increased from 1500 rpm until 4000 rpm. Because butanol helps combustion at low rpm to burn faster, and combustion in the combustion chamber is more efficient. But in 5000 until 8000 rpm, torque decrease. Higher percentage of butanol in mixture cause an inhomogeneous mixture and can cause incomplete combustion. Therefore, the torque might decrease at high rpm. Based on graphic, the high horsepower is produced by the ignition timing of 2 degree forward from standard. It produces 14.5 HP at 4000 rpm, and standard is 13.9 HP at the same rpm. The horsepower of dual fuel modification has increased from the standard because mixing butanol makes the ignition point just right, because butanol it has a lower flash point than gasoline. This is because the high rpm it is necessary to adjust the fuel setting so that complete combustion and power generated when revs up better. Fuel consumption. Fuel consumption when 100, 500 until 4000 rpm, fuel consumption decrease, and after 4000 rpm, fuel consumption decrease. The addition of butanol in the combustion chamber caused the AFR value to be increased. Because the content of butanol has a high oxygen value, which is the higher than pertamax, so that the oxygen content in butanol causes combustion to be more efficient than using only pertamax fuel. This cause to the same operation condition, the engine needs to burn more blends of butanol pertamax than pure pertamax. Efficiency thermal. Based on the high efficiency thermal is standard, it produces 38% at 4000 rpm. It means the standard ignition timing has a best efficiency thermal. That means at 4000 rpm, the mixture fuel and air has a stoichiometry combustion. Next, gas emission test. Gas emission test use a gas analyzer to see what gas that combustion chamber produce. There is a carbon dioxide, carbon monoxide, hydrocarbon, and oxygen. The result of gas emission is like this, and I summarize like that. Based on graph, the modification to a file system emission is lower than a standard fuel pertamax because butanol make a effect perfect combustion and the gas that produced can decrease. Conclusion: design on fuel butanol injection into the combustion chamber using dual injector system using throttle body Honda CP100R, which allows the additional of double injector. The butanol injector can be controlled by a programmable ECU. Programmable ECU controls standard ignition engine variation 2 degree forward from the standard and 4 degree forward from the standard. And under conclusion, you can see 2 and 3. After that, thank you. Do you have any question?